started off looking at what do we mean by random experiment, outcomes, events, and sample space. We now want to look at a couple of examples of all of the things that we've looked at. So we want to start looking at some examples. We'll look at 3 examples. So the first example that we're going to look at is going to be of a random experiment which involves tossing 2 coins, right? So the first example is going to be, remember, random experiment is any experiment that has an uncertain outcome. An uncertain outcome means an outcome that we don't know in advance. So the first example we're going to look at is a random experiment of tossing 2 coins. Now, let's write down any 2 outcomes of this. We know outcomes are, an outcome is a possible result of the random experiment's outcomes. So let's write down any 2 outcomes. So let's write down any 2 outcomes. So one outcome could be head and tail, and another outcome could be tail and head. So we've written down any 2 outcomes of this. Now let's write down our sample space. Sample space is the set of all outcomes of the random experiment. Now you can always use the basic counting principle in this case in order to figure out how many total outcomes will we have, right? So we can use the basic counting principle. So all possible outcomes, because remember, sample space is a set of all outcomes of the random experiment. So all possible outcomes according to principle of counting, according to basic principle of counting, according to counting principle or principle of counting, counting to counting principle are. So we know the first coin toss can result in 2 possible outcomes, head or tail, and the second coin toss can result in 2 possible outcomes, head or tails. According to the basic counting principle, the total number of outcomes that we can have when you perform both of them together are going to be 2 into 2, which is 4, right? So we know, okay, our sample space is a set of all possible outcomes, and using the basic counting principle, we know that there will be total 4 outcomes, right? So our sample space, we know it's a set of all possible outcomes, and using the basic counting principle, we already know without even writing the outcomes that there will be 4 possible outcomes, which are going to be head and tail. There are going to be head and tail, it's going to be tail and head, it's going to be head and head, and it's going to be tail and tail. So remember, just keep in mind, sample space is the set of all possible outcomes, and using the basic counting principle, we already know for this random experiment there will be 4 possible outcomes that we can write down now. Now let's look at some events. Now recall, events are subsets of the sample space, right? So they include 0 or more outcomes. Now let's define one event E1 as the first coin lands on head. This is the first coin lands on heads. This is the first event that we've defined in this case. So now this is going to be head, tail, and it's going to be head and head, right? This is event. Remember, it's a subset of the sample space. So here from the sample space, it includes 2 outcomes, head, tail, and head, head. We're the first event. Where the first point lands in here, right? So it consists of 2 outcomes in sample space. Consists of 2 outcomes from sample space, because remember, it's a subset of the sample space, so all of its elements are contained within the sample space. 2 elements from sample space. So this is one event. Let's define another event, E2. E2 is both coins land on head. Both coins land on head. So this event is just made up of one outcome from the sample space, head head. Just remember, event is a subset of the sample space, so event, like the sample space, is a set itself, right? So it consists of one outcome from the sample space, right? So it consists of one outcome from the sample space. So here note that the events are a subset of S always, right? So they're always a subset of the sample space, which means they all elements contained inside these events come from the sample space. So this was the first example that we looked at, tossing 2 coins. Let's look at another example. So example 2 is, let's say now we're tossing 3 coins. Now let's have another random experiment where we're tossing 3 coins. So let's look at tossing 3 coins instead of 2 now. So now let's look at outcomes, any one. Let's just write any one outcome. we know outcome is a possible result of the random experiment. So any one, let's write down any one outcome. So any one outcome could be head, head, head. Yes, that's one outcome. Now let's write down our sample space. Now we know our sample space is the set of all possible outcomes. So now possible outcomes. Now again, you can use the basic counting principle to figure out how many possible outcomes would we have before writing them out. So possible outcomes according to counting principle. So if we use the principle of counting according to counting principle, we can figure out how many outcomes should be in the sample space. According to counting principle, are going to be, okay, principle, we know the first coin can result in two outcomes, the second coin can result in two outcomes, the third coin can result in two outcomes. So together, if we toss three coins, so according to the counting principle, we'll get 8 possible outcomes. Right, so over here, our sample space is a set of all possible outcomes. And using the counting principle, we know we'll have 8 outcomes. What will those 8 outcomes be? We can have all three head, and then we can have the first two heads, and then a tail. Then we can have the first is a head, and the second is a tail, and the third is a head. And then we can have one tail, the first is tail, and then we have two heads. And then here we can have all three tails, right? Sorry, then we can have all three tails. Then we can have a tail, then head, tail. So these are all the possible outcomes that we can have. Then you can have first two tails and then a head. And then you can have head, tail, tail, right? So this is the sample space. The sample space is a set of all possible outcomes. Here we just specified one outcome, right? This head, head, head. But here we can have 8 possible outcomes. And even before writing the sample space, meaning through the basic counting principle, there'll be 8 possible outcomes. Now let's write down a couple of events related to this random experiment. The first one we can define as the first coin lands on tails. Right, so this event will include which outcomes in the sample space? The first coin lands on tails. So it will include this outcome from the sample space. So tail, head, head. It will include this outcome from the sample space, tail, tail, tail. It will include coin lands on head. So it will include this one from the sample space, tail, head, tail. And it would include this one, tail, tail, head, right? So it consists of 4 outcomes from the sample space. Consists of 4 outcomes from sample space. 4 outcomes from sample space. Now we can define another event here, E2. E2 is going to be, let's define it to be exactly 2 heads. So from the sample space, this includes which outcomes? This will include this outcome, right? Where you have head, head, and tail, right? This one. It can include this where you have head, tail, head. And then it includes this as well, where you have tail, head, head. And then it includes, doesn't include this. Here you have two tails, one head, right? So this, right? So it includes this also. This consists of 3 outcomes from sample space, right? So because remember, events are subsets of the sample space. They're also sets which contain 0 or more outcomes from the sample space. 3 outcomes from sample space. So we can define this event in this case. Okay. So so in this case, now let's look at the last example. Example 3 is where 2 dice are rolled. Now let's look at another random experiment where 2 dice are rolled. Now the next random experiment that we want to look at is 2 dice are rolled. Here, let's write down the outcomes. Let's write down again any one outcome of this random experiment, any one. So one outcome could be the first is for the first lands on a 1 and the second lands on a 1 as well. And then if we write the sample space, this is the set of all possible outcomes, right? And using the basic counting principle, we can first figure out how many outcomes would we have. So possible outcomes possible outcomes are based using counting principle. Using counting principle, so the first coin can result in 6 possible outcomes, the second coin can result in 6 possible outcomes. So together they can result in 36 possible outcomes. So when we write its sample space as a set, right? So it will have 36 possible outcomes, starting with the both landing on 1, then the first landing on 1, second landing on 2, then the first landing on 1, second landing on 3, and so on, till you have both landing on 6, right? So you'll have a total of 36 outcomes over here. So you'll have total 36 different outcomes. So you'll have total 36 outcomes here, where both can land on 1. The first lands on 1 and the second lands on 2. And the first lands on 1, the second lands on 3, and so on. So now we'll define our events in this case. The first event, let's define as the sum of two dice is 10. So in this case, the sum of the two dice is 10. So it could be that the first is 4 and the second is 6. It could be the first is 6 and the second is 4. And it could be the first is 5 and the second is 5, right? So sum of two dice is 10. So we can have 3 possible outcomes from the sample space here. Then we can have another event that we can define, E2. Same number appears on both dice. So this can have which outcomes? It can have 1 and 1, both have 1, both have 2, both have 3, both have 4, both have 5, and both have 6. So there are 6 possible outcomes from the sample space. So this consists of 6 outcomes from the sample space. So here the key thing to remember is a random experiment is any experiment that has an uncertain outcome. By uncertain outcome, we mean an outcome that we don't know in advance until we perform the random experiment. We know what outcomes could occur, but we don't know exactly what outcome will occur unless we perform the random experiment. And an outcome is a possible result of the random experiment. Sample space is the set of all those possible outcomes. An event is a subset of the sample space. Since it's a subset of the sample space, it's a set itself with 0 or more outcomes from the sample space.